is not for you. Okay, so this is the exact same thing as this. XY equals 3Y. So these are exactly the same thing. So I'm going to give you a minute. Did he have you all copy? Did you copy this question down? If you haven't, I'll stop for you all to copy it down. Go ahead and copy this down. I'm just writing this above because we're going to use the same process to solve this that we would if it were this. We're going to set it equal to 0 and take out our GCF. That's what you're going to do with this. And I don't really like theta, so I'm going to put an X there instead because it's just easier for me to make an X. I'm using Mr. Suchi's slides, but I'm just going to put an X instead of theta. All right, so take about 60 seconds because you said you have not copied this down, or have you copied these down? All right, so take about 60 seconds. Let's go. We got about 4 questions to do. Now, it's impossible for me to solve every single question that's going to be on the test. Okay. I think the main thing is to think of it algebraically. That's the issue. Because I know most of you took geometry last year. So we have to remember how to solve equations. So that might be the struggle. So if it were this in Algebra 1, you would set it equal to 0 first by subtracting the 3y. That's what you're going to do with this one in pre-cal. You're going to bring this, Jasmine, are you paying attention? You're going to bring this over. So you're going to take this 3 cosine x and bring it across. So when I bring this across, I get cosine x sine x minus 3 cosine x equals 0.
So are cosine x and sine x still being multiplied together?
Yes. And because they're being multiplied, we can take out the GCF. So what is my greatest common factor? What do you see for both terms? What do they both have?
X.
True. What else do they both have? Cosine. So what we're going to do is take out my greatest common factor, which is cosine. And when you take out cosine, that's on the outside. What would be left inside of our parentheses? What didn't we take out? Sine x minus 3. That would be left inside. So these are 2 factors. So now we're going to set both of these factors equal to 0. So this is my first factor. Cosine x equals 0. Solve that. Well, that's already solved. So you're going to tell me on your unit circle. Take out your unit circle. What angles have a cosine of 0? So there should be 2 angles that have a cosine of 0. Yep, so pi over 2 and 3 pi over 2. I want to make sure you see this part here. This is really important. Where it says the interval, that means I'm going from 0 to 2 pi. Notice that 0 is included because it has a bracket. 2 pi is not because it has a parentheses. All right, so now we're going to take our second factor, which is sine x minus 3 equals 0. So in order to solve that, how would I solve that for x? Add 3. Where on your unit circle is sine equal to 3? Is sine ever equal to 3? So this does not exist. And these would be the solutions that you would tell me. For question B, if I go back to this one, B is just like x squared plus x equals 0. What would you do? What would you take out? What would be your GCF? X. And if you took out the x, what would be left over? Inside of the parentheses, what would you have? X. What would be left inside? Plus 1. So that thinking is the exact same thing we're going to do for this next question. So if you haven't already, copy down question B. And this time your GCF is tangent. And again, I don't like theta. I'm going to put an X. So instead of throwing them away, I'm just passing them out. The people who I didn't see. Hi. Can you hand me that stack? I'm going to hand you yours. So yeah, I printed them out because we had conferences. What was that, Thursday?
Yeah.
So I printed them out for all 130 students. So instead of throwing them in the trash, thank you. Just thought I'd hand them to you. All right, so let's go ahead and take out our GCF, which in this example would be tangent. And then what would be left inside of the parentheses? 10x plus 1, just like this one here. It's exactly the same thing, except it has a tangent. For those who came in late, we do have a study guide in the chair in the front. Oh, I moved it to the desk. But there's a study guide, and you do not have to do numbers 23 and 24. So Mike and Say, it's right there in front of you. So you can cross off 23 and 24. Our quiz is this Friday. So now you're going to set both of these equal to 0. So your first one, this is your first factor, tangent. So on the unit circle, you're going to tell me where is tangent equal to 0. So tangent is sine over cosine. So where is tangent equal to 0? Tangent is undefined at pi over 2 and 3 pi over 2. But it equals 0 because remember, you can take 0 divided by 1. 0 divided by 1 is 0. But 1 divided by 0 is undefined. So where would tangent equal 0? What would be your two answers for that first one? Pi over, nope, not pi over 2. Pi and what else? And 2, nope. Pi and where else? Because remember, look at the interval. 2 pi can't be an answer.
Oh.
0. So 0 and pi are your 2 answers. Now let's do the same thing with our second factor. Tangent x plus 1 equals 0. So I didn't hear you.
You got the answers
From the unit circle. Yes, ma'am. And then tangent of x equals, so how would I solve this one? If tan x plus 1 equals 0, what is tangent? -1. So what 2 quadrants are you looking in? Where is tangent negative? 4. And what else? And 2. So that would be your 45, 45, 90s. So I know that it's going to be, let me see, 1, 2, 3 pi over 4. Because if you take root 2 over 2 divided by negative root 2 over 2, you get -1. There's a study guide right next to Marisol. And then where else? So we gotta look at our interval. Let's look at our interval. What does it say? Our answers have to fall between 0 and 360. So negative pi over 2 would be -45. So that's not inside of our interval. So what would you tell me for my second answer? 7 pi over 4. All right, any questions? Okay, I'm going to skip ahead a little bit and come back to the one where we have to factor. I'm going to come back to this. All right, go ahead and copy down these 2, because these go pretty fast. Pass that back for me. Okay, so for this first one, we're going to solve for secant. So in order to solve for secant, what do you think we're going to do first to solve for secant? So it's not squared, so we don't need to set it equal to 0. So, but not subtract 11, though. So we're trying to get this by itself. So what would I subtract? 2 root 2. So going back to first semester and also Algebra 1, the only way you can subtract is if you have the same number under the radical, and you see how these both have a root 2? That means that they're like terms. So you have 9 times the secant of x. And 11 minus 2 is 9 root 2. Now to get rid of that 9, we're going to divide it. So you're left with secant of x equals the square root of 2. So I recognize that this is the same as cosine of root 2 over 2. And that's what I recognize. That's what I recommend you do on the test. If it's secant, let's write it in terms of its sister. So we know secant is the sister to cosine. So this is the same thing as saying cosine of x equals, you're going to flip that. And if you flip it, it becomes 1 over the square root of 2. And then what do you have to do because you have a square root in your denominator? How do you get rid of a square root in your denominator? Yeah, rationalize it. I heard rationalize. Good job. Multiply by root 2. So that will give you root 2 over 2. So what you need to understand on the test is that secant x equals root 2 is the same thing as the cosine of x equals root 2 over 2. These are the exact same thing. So on your unit circle, you're going to tell me where is cosine equal to positive root 2 over 2. So I'm looking for 2 answers because we're looking, you got to look at, always check your interval. Notice your interval says 0 to 2 pi. So you're looking at all 4 quadrants.
Is it pi over 4 and 7 pi?
Yes. It should be quadrants 1 and quadrant 4. So your 2 solutions would be x equals pi over 4 and 7 pi over 4. All right, I'll give you a minute to copy down B if you haven't already. And B, I'm going to give you a minute because I bet you could do that by yourself because we kind of did that already. I feel like we did the same question, so I'm going to give you a couple of minutes to try to do that one by yourself. And I'll just give you a hint. We're looking for 4 answers. There's 4 answers to this. Four angles on the unit circle.
So is it 1 for each quadrant?
Hi. I had a migraine. I think it's just because I don't know, I just have a migraine.
This makes sense now. I was struggling with the same question for 4 days. I forgot that you're supposed to use the sister function.
Yeah.
So I was like, where do I find cotangent?
Can't find cotangent, but you can find tangent. So what was your first step? What did you do first? Divide by 4. That's what I would do. And then what would be your second step? Square root. When you square root a fraction, you're really square rooting. Here, let me go ahead and back up. Numerator and denominator. That's how you square root a fraction. Luckily for us, they're both perfect squares. And what is the square root of 1/4? Plus or minus 2?
What happened?
Plus or minus 1/2.
Oh, there's,
So what are your angles that have a sine value of positive 1/2 or negative 1/2? So in quadrant 1, let's just go around. Let's just first look in quadrant 1. I don't have my unit circle, but I think it's pi over 6.
Yeah.
Quadrant 2, 2, 3, 4, 5. Is it 5 pi over
I
6?
think they're all the same.
They all have a 6, yep.
Yeah.
And then what is it in quadrant 3?
7, 5, or 6.
And then in quadrant 4?
I'm gonna be pi over 6.
Yes. Kimmy, there is a review back there for Friday's quiz. You can cross out numbers 23 and 24. So we're not doing those 2 questions. All right, so now let's do the hardest one, which involves the Pythagorean identity. So we're only going to do one more question and then we'll be finished for today. But before we do that one question, you don't have to write all of this down. This is the most important thing to write down right here. You all have already heard of the Pythagorean theorem, right? What is the Pythagorean theorem? A squared plus B squared equals C squared. Well, this also applies to the unit circle. And you will need to use this to solve certain equations. So this is the exact same thing. On the unit circle, we have A, which is your cosine. That's X, or whichever one. So we have this side squared plus this side squared equals the radius. And the radius of a unit circle is 1. So I'll give you a minute. You only need to copy down what I have highlighted in green, though. And then we have one more equation that we're going to solve, and then we will be finished for today. Here, let me zoom out for you.
Should I have nap during government or outward cognitive, or should I have taken work during?
Do you have work? We have hired. We have. Shoot,
Do you have regular gov or AP?
I had regular hill.
We have
I might need AP go for.
you have Mr. Where's
I had Miss oh my gosh, Miss Heck.
I know Professor Lawrence, we have a project due.
Okay, so this is our last one. We're only going to do question A because I believe B has a typo in it. So I'm going to give you a second to just copy down. This is what you've already written down. You've already wrote this down. But this is important where it says find all real solutions because we haven't done one like this before. So I want you to write that down and then copy this down. And then we're going to really slowly work through this question, and this will be our last one. This will be on your test Friday. I'm saying test, but it's a quiz. This will be on Friday's quiz. You have the review. I'm going to post the answer key. I'm going to really try to post it today during 4th period. That is my goal. So the reason why this one is harder, well, first let me ask you, what do you notice is different about this one? I don't know if you'll notice it, but this one is definitely different from the one that Mr. Suchi did, I believe, on Wednesday. Because you've already had to factor. But this one is different, though.
Has no GC.
Doesn't have a GCF. That's a good thing I want you to recognize. So if I go back, I'm going to scroll back to the one we did earlier today. So we look at this one. This one had sine and cosine in it, but it had a GCF. okay? We look at this one, we have a sine and a cosine, but we don't have a GCF. When you see a question like this on Friday, the only way to do this is to do a substitution. I need to substitute this. This needs to come out. And I need to figure out another way to write cosine squared. And I'm going to do that using this Pythagorean identity. If you take this Pythagorean identity that you just wrote down and solve it for cosine, that would mean that I would take the sine squared and subtract it. That would mean that I would have cosine squared theta equals what? 1. And then if I subtract the sine squared from both sides, what would I have? 1 minus sine squared x. You can rearrange this two different ways. You can rearrange it as cosine squared equals 1 minus sine squared, or you can rearrange it as sine squared equals 1 minus cosine squared. I'm going to have you all write that down. That's two different ways to rearrange that identity. So you can arrange it so that you're solving that identity, that Pythagorean theorem, that Pythagorean identity. We can solve it for cosine squared, or we can solve it for sine squared. In this example, we're going to solve it for cosine squared because that's what we have in this example. We don't have a sine squared. So we're going to use this substitution. So I'm going to take this.
Why'd you use theta and x?
That is just a very bad habit I have of going back and forth like that. It should be one or the other. You pick. I don't really like theta because it's hard for me to write theta, so I always change it to x subconsciously. But it's just a variable, and you can use either one, whichever one you want to. So even on the test, if it's written with theta and you don't want to write theta, you want to write it with x, you can always do that. You can always change the variable. Like that's okay. All right, so what I'm going to do is rewrite this equation where it says 2 cosine. I'm going to put parentheses and then 3 sine theta. I'm going to put an x though, because I don't want to do theta. And then inside of the parentheses, I'm going to do a substitution. Instead of cosine squared, what is cosine squared equal? 1 minus sine squared. And that's what I'm going to put here. So what I'm trying to do here is rewrite this so that it just has one trig ratio. Because if you don't have a GCF, we can't solve it if it has two different ratios. So now we only have one ratio, which is sine. All right, so now we're just going to use our algebra skills. So the next thing we're going to do is distribute this 2. Take the 2 and distribute that, which gives you 2 minus, so 2 times 1 is 2. What is 2 times sine squared x? What do you?
Sine squared 2x.
Yep, 2 sine squared x. All right, now what would you do? Look for what? Look for like terms. Do you have any like terms?
-3 and 2.
Yep, the -3 and the 2. So that would be a -2 sine squared x plus 3 sine x. And what is 2 plus -3? What do you get when you combine those two like terms? 2, -1, good. Okay, so I know most of you all took geometry last year, so you may not remember this rule in factoring. When you factor, actually I'm going to do my u substitution right now. I'm going to write this. I'm going to say u equals sine x. So I'm going to rewrite this with the letter u because I think it's easier for you all. That's just my opinion. A lot of teachers don't rewrite it with the u, but I think it's just easier to factor without sine. Okay, so now we're ready to factor, but we have a problem. Does anybody recognize what that problem is?
Not factorable.
In order to factor, one of these numbers has to be positive.
Factor -1.
Yeah, that a, you cannot factor, and that's why I didn't think you all would remember this. But you can factor it out or multiply it by -1. That's the same thing. In other words, we're gonna change our signs. So now this becomes positive 2u squared, and then that becomes a negative 3u. That becomes a positive 1 equals 0. So I want you all to factor that down by yourself. This is not an algebra class. This is pre-calc. I expect for you to be able to factor. I want you to factor and solve that equation. And I will tell you one of your answers will be a fraction. So I'm going to give you a minute to do that. This is our last question. So we have time. So you will have to make a box to factor this because a is 2. You cannot do a shortcut. Yeah. I'm gonna see if you got your 2 answers. So what's that? Oh, so what did you get here? If this is negative, you had- Oh, okay. Make our box.
I told you this on Friday.
You have to do X first. That's what the X, like the X.
We did this on Wednesday.
And then you sum it. Those can see that goes in the box.
This one, I'm just trying to make it.
So I'll put that up for you who didn't get, but you should have had u equals positive 1/2 and u equals positive 1. Who had that? But now we know, but what is u? U is really what? Sine. So you're going to go to your unit circle and tell me where is sine 1/2 and where is sine 1. So there are 2 places on your unit circle. Now, because it says for all real solutions, there is a little bit of a trick. So what's your first place in quadrant 1? Where is sine 1/2? Pi over 6 or pi over 3? Pi over 6. So because it says all real solution, you have to say plus minus 2 pi n. So in other words, it says all real. So not just saying where, it's not asking for only the place on the unit circle. It's saying all of the places. Anytime it says, and I'm going to go back, I'm going to zoom back out in a minute. And then where other place is sign 1/2? Sign positive. Sign is positive in quadrants 1 and 2. 5 pi over 6 plus 2 pi n. Okay, and where's sign 1? Pi over 2 plus 2 pi n. So I'm going to talk about that plus 2 pi n. You only add that plus 2 pi n when it says, let me zoom way back out. I hate to zoom out. Is when it says all real solutions. Whenever it says all real solutions, that means you have to add plus 2 pi n.
Is it 2 pi just 360?
Yes. And because we're in radians, that's why we said 2 pi. All right, that's actually it for today. We will be reviewing for the next 2 days. Homework 8, I believe Mr. Suchi said is due Thursday, but check Canvas because I don't remember.